My name is Pete, and I work with Aleph 0. And today, alongside my colleague and actually our co-founder Adam, we're gonna tell you a bit about our Shielder, which is our latest privacy offering, and our smart contracts and our blockchain and everything. So this is meant to be, on my side, a very practical introduction for those interested in building with Aleph 0. Adam's part, which comes at the end, will contain a lot more, higher science and looking into the future. So please stay for that as well. Oh, I'm going to take the clicker. Okay. Right. So in case you want to go hack on your projects, and I want to be completely transparent here, and I'm going to say what I'm going to say. First, I'm going to do a very short intro to Aleph 0 as a blockchain, as a platform. Then we're going to take a look at the Shielder, a very, very broad overview, bird's eye view, basically. Then I'm going to do a short demo of the Shielder. Next, we're going to take a look at the Ink smart contracts. I'm sure a lot of you already know how to write Ink smart contracts, but hey, that's what I do. I talk about Ink, so I'm going to do just that. Then a short demo of how to create a PSP22 token on Aleph 0 using OpenBrush, the library. And then comes Adam's part with the kind of future of DeFi in context of privacy and the Shielder and possible extensions and whatnot. It's going to be good. Stay tuned for that. Okay, so the context of this whole talk is Aleph 0, our layer 1 proof-of-stake blockchain with some nice privacy solutions, very fast finality, time to finality, very low transaction cost. Sounds good, doesn't it? And then, well, we have smart contracts in Ink, and actually, as of last week, they are deployed on mainnet. There's some products being ran. There's some, protocols. Sorry? This week. Yeah, it was this week. Well, the release date is in the past. It's already released. You can even mint yourself an NFT if you're into that. So yeah, this is for the useful links in case you want to, interactively follow along, or even just, to make it handy for you to play around with the chain and with the smart contracts. This QR code is actually the first link, our main website, which in I think at most 2 hops will lead you to all of the other stuff. So yeah, you can scan that. I see someone scanning. That's good. Yeah, please do. Or you can just type in the addresses. They're not super complicated. Everyone done? Oh no. See, I'm never on time with scanning, so I want to give you some room. All done? Cool. That's very cool. Okay, so this is maybe a bit trivial, but and pretty apparent to everyone. But in a lot of use cases, we don't want to reveal exactly what we are doing, exactly what funds are being sent where. The whole privacy thing. So examples of such settings in which you want to, hide something from the prying eye would be, for example, voting, as seen in DAOs. So private voting, really cool. And I guess voting in general. Yeah, imagine that voting in a country should be private, ideally. Then ZK identity, KYC, KYB. Also really cool if not everyone sees a scan of your ID. Dark pools, so if you want to, for example, sell a lot of some asset without impacting the market price, that's also a good use case for privacy. And as we will see later with Adam's talk, actually DeFi, the privacy fits very well and can give you some serious, value added. Let's move on. So what we are proposing here, and mind you that this is, of course, live in a sense that you can, as a developer, go to the repository and play with it. It's actually very convenient, as we're going to see later. But of course, the work never stops. The building never stops. We are constantly working on adding new features and new extensions and whatnot. But what I would like to present here now is basically a private wallet. So imagine a place where you can send your assets, and they are completely, private there in a sense that I cannot go into the shielder and say that, okay, I see that you've got X of some token, right? You can just see the overall amounts of tokens in the shielder, but not individual account balances. And then, of course, you can withdraw to your own account or to another account, thereby, having something like shielded transfers. As we are going to see later, this is actually hugely expressive and can allow you to interact with a whole range of DeFi products in a, well, I wouldn't say private, but like more private way. Shielded way is perhaps the word. Yeah, of course, there's some. The privacy land here is basically short for some ZK snark magic I don't really have the grasp of, but yeah, I trust the people who built it. They are smart people, and yeah, I think it works. You can check out for yourself in the repo, which, by the way, is here. If you choose to scan this one, you'll have the Shielder GitHub repository, which is quite cool because, as we're going to see in just a moment, it's actually extremely easy to set up and to play around with and to experiment and to even extend. Yeah, you're scanning. That's cool. I actually have the very same QR code on the next slide as well. So I think in like 5 seconds I'm going to switch, but the code is going to stay. There you go. So first of all, what I myself dislike about bootstrapping like programming projects is the number of dependencies. Here, that's not the case because for like your most basic use case and getting to know Shielder, you just need Docker, obviously. Docker Compose in the standalone version. This will probably change, but for now it's the standalone version, so the one with the with the hyphen, and JQ, which is the JSON thing, the library that can parse JSON and process JSON. If you're going to play around more with the Shielder and more specifically with the cargo contracts, or if you want to build Shielder yourself and so on, you will eventually need Rust and Cargo, the usual combo, but also the Cargo contract extension. That's like a manager for the smart contracts. Oh, I have this. Cool. Yeah. So once you're done with the previous slide, and this is pretty amazing because you just use this magical script and yeah, it just spews a lot of output, and there you have it, like a few Docker containers, some contracts, some accounts set up. So basically, you don't need to do any of the grunt work of having to, launch some instances, launching a local chain, bootstrapping the accounts and everything. That's just there for you to play with. So I would say it took me like all of 5 minutes to actually get to the real deal. And like I said, I'm not one of the developers working on that. So yeah, I'm a good benchmark actually. Yeah. Oh, by the way, if you're following this along, which maybe someone is, then the accounts we're going to use whenever Shielder asks you for the seed would be Damian and Hans, which is //0 and //1. In the real setting, you'd probably use very different seeds, but this is just a, we'll be working within the context of like a local chain and local instances. So that's just convenient. I have this, I keep forgetting. Yeah, so basically the Shielder contains like 3 folders, one for the deploy, one for the contracts, or actually 4 maybe, right? One for the tokens, and one for the CLI. And inside, it should already be built, but if you don't have this binary in your target/release folder, in the CLI you can just run cargo build --release, and it will be built for you, and then you can just use the binary. So first, what we can do is show the assets that are inside the shielder, and I'm very much at conflict with myself whether I want to actually show you how this works with a live demo. Maybe later. Actually, maybe later. So yeah, this will just show you the assets, and I think without loss of generality, I can say that those will be the assets that you deposit into the shielder, right? So you won't be able to snoop on anyone else. But in order to have some assets to show, you're going to want to deposit something into the shielder. I have an error here. It's actually, it deposits 100 monies, not 10. But that's okay. The 0 here is the index of the smart contract. In the default setup, you will have 2. So here we're using the first smart contract. So those are like 2 PSP22 tokens. If you are not familiar with PSP22, it's like ERC20, basically. Lots of acronyms, I guess, but that's okay. It's very simple. Yeah, so once you deposit, of course, you can withdraw. Well, you can withdraw what you've deposited, or you can withdraw less, in which case the shielder will internally do its crypto magic and update your balance. Also, it will make sure that you're not withdrawing more than you've deposited. This would be bad. You need to supply the deposit ID. If you're doing the show assets, you're going to see which deposit has which ID, so it's pretty straightforward. Of course, you need to give it the amount. But the API is just as simple as that. One cool thing is that you don't really need to deposit into your own account. You can deposit into, well, someone else's account, which is kind of like a shielded transfer. Here, actually, maybe I'll pause the slides, because this account here is one of the accounts already bootstrapped in the project. Which you can, by the way, learn by inspecting the deploy.sh file. So it works actually the same way as regular withdrawal. You just supply the recipient field. And yeah, just like that, and that's pretty much it when it comes to the user-facing side of the shielder. Now, what you choose to do with it is a whole other story, but I think Adam is gonna get to that in just a few minutes, actually. But yeah, I would say that simplicity is the ultimate complexity, as someone said. I don't know who, Mick Jagger maybe. Yeah, so here I wanted to kind of swerve towards familiar territory, because when you're shielding assets with Shielder, obviously you'll need to have some assets to shield. And on Aleph 0, you'll most probably want to do that in ink. Actually, it's interesting because you theoretically wouldn't have to do it in ink. You can do it in anything that compiles to WASM, but in ink is basically the simplest way. So what's ink? Well, ink is an EDSL for Rust. That stands for Embedded Domain Specific Language, which is a fancy word for, well, ink being basically a subset of Rust with some additional macros that take care of a few things for you. So it's actually really cool that you don't have to learn a separate language. You don't have this overhead. If you know Rust, you can just start writing. But if you don't know Rust, actually ink is very simple to learn, because ink is arguably way less complex than the full Rust language with all its constructs. So we think Rust is pretty cool because it's a modern language. It has quite evidently been designed by someone who has done his research, but at the same time was very practical when doing so. So yeah, really cool features. Type safety without really some weird constructs. Memory safety without overhead, which is actually really cool. The tooling is good for Rust, and Rust constantly keeps winning Stack Overflow surveys for the most liked language by the developers. So I think that counts for something. Now, the flavor of Rust we are using here, or basically the compiler backend we're using here, is WASM, which you probably know, right? WebAssembly, which is cool because it's ubiquitous in the sense that it's supported by everything. It's fast and secure. I'm not gonna dive into the security of WASM, but But something I want to touch upon, and please don't pay too close attention to this table, because it's mostly a pretext for me to talk about differences and similarities between Solidity and Ink, because, well, most of the developers will be probably coming from Solidity or will have some prior experience. So basically, like a soft guarantee I'm giving to our projects is that more or less the concepts from Solidity map one-to-one to Rust, right? Or to Ink in that case. So it's, well, you'll probably have to use a slightly different syntax and maybe express the concepts in slightly a different way, but there's no fundamental like differences in philosophy. I would say Ink is slightly safer and, at least to me, provides less pitfalls and ways of shooting yourself in the foot, but, well, that's for you to decide. Just, you know, go and check it out. It's actually fairly easy to port most Solidity contracts, and a lot of teams have already done so. Now, this is just for the curious, but this is basically what I'm interested in, so I decided I'm going to put it here. So when you take a look at, well, if you compile the contract to WASM, and then, well, then you basically get a binary blob that tells you nothing. But you can use like a decompiler to retrieve the, well, let's say, assembly form of WASM, well, like text form of WASM. And now, if you look closely, you will see it's very familiar to Lisp. If anyone has ever used like Racket or Scheme or Clojure, then you will be very familiar with how this looks like. And the interesting thing about the execution of WASM is that it's actually a stack machine, right? So a concept so simple that it's actually beautiful. Yeah, basically all your program, you know, execution boils down to like popping things off the stack. It's really beautiful. Okay. Yeah, so this is yet another slide that's here. You can basically treat it as a picture and not as text, really. So this is a bird's eye view of how you interact with a contract from your machine, right? You first need to install some required tooling. Then you bootstrap the contract by writing cargo contract new. Then you write your code. But a lot of the structure is actually set up for you by the cargo contract new call. So you just, you know, change the logic, add some fields, and so on as you do, and then you simply, well, first test, then you build the release package, and you're left with some artifacts. The first one is the WASM blob, the actual code. The second artifact is a JSON file with the metadata, which basically allows the chain to display, you know, like doc strings about your code, and allows other software to find basically what is where in your code in the binary blob, and also the two bundled together. If you see my lame joke on this slide, then good for you. I'm not going to embarrass myself any further. Also, I think it's worth noting that there already exists some tooling for Ink that allows you to bootstrap the development much quicker. You can check out Inkathon by one of our community members, and also OpenBrush that I'm going to talk about in just a second. Yeah, so sorry for pasting a blob of code on the slide, but this goes to show that basically implementing this PSP22 code, which is basically Polkadot for ERC20, like I mentioned before, it's just simple as that. A few imports, a few macros, then all you need to do is implement the PSP22 trait. Do I have a laser pointer here? Whoa, look at that. Implement the PSP22 trait, and then decide what you'll be supplying on contract creation, instantiation in the constructor. Then it's pretty self-explanatory because you need to mint the new token with some initial supply, and just like that, you're done, right? Also, every contract needs to have the storage struct. By the way, it's only allowed to have exactly one. Well, you need to mark the fields. That's just OpenBrush stuff. but yeah, that's pretty much it. That's how you define a fully working, PSP22 token with OpenBrush. Now, the cool thing about this is how modular it is. So let's say I want to extend the token and be able to mint it, right? So just like that, well, there's also some imports that I skipped, but you'll be able to find that in the docs really easily. But what I'm doing is basically implementing a trait for the mintable extension, and then just like delegating to one of the internal methods, and boom, you can mint the token. Now, what's even cooler, you can take a look at the modifiers only owner, because we want to make sure that some of the functions are that only the owner can call them. So what you do is you use another Lego block, right? You can implement the ownable trait for your contract. And yeah, you can use those modifiers only owner. So basically what it will do automatically is when someone calls this message, it will check whether the account of the caller is the same as the account of the person that instantiated the contract in the first place, right? That's simple as that. We have some more expressive means of access control in our GitHub org. You're very welcome to take a look. Yeah, so this basically concludes my part, which was, like I said, very practical. I hope so, at least. So yeah, the shielder is, like I said, pretty expressive as it is, simple but expressive. It's actually, the complexity is under the hood, but to the user it's very simple, but you can build a lot of interesting things with it. But now, if you'd like to see what the future holds, or we'll be building in the future and what we'll be working on, I would like to invite you to listen to our co-founder, Adam. Yeah, thank you.
How do I click? Oh, okay. So here's me with more theoretical part, which is a nice word for not practical, or not practical yet. Here's more like vision, or how we would like Shielder to be used now and in the future. So we initially at least want to use it as a mean to integrate with DeFi. So first, what is DeFi, or maybe how it usually works? So I'd like to claim that DeFi basically operates with one single interaction pattern, which is there's a user, or actually a contract, which sends some tokens and some data to smart contract, which then sends back some other tokens and sometimes some other data, but usually just tokens. So the obvious example here is the decentralized exchange. Oh, by the way, it's like, I'm not gonna talk much about ink and code anymore, so probably it's less useful for the hackathon itself, but it's not gonna be very long. So the obvious example is decentralized exchange. So Bob can, for example, send some USDT and some additional data, for example, slippage tolerance. So like, what's the worst price Bob is willing to accept? And then DEX will do some internal computation and will send back some USDC tokens. Or perhaps transaction can also fail if preferred price will not be matched. So maybe it's not obvious at the first glance, but actually, I mean, the case of DEX is obvious, but the other are maybe not, or maybe less. But the DEXs look the same for liquidity providers. So what happens with liquidity providers? They are providing some liquidity, and they are also getting some tokens in return, namely so-called LP tokens, which represents their rights to reclaim the liquidity they provide. The same for lending protocols. So you put some collaterals, you get some tokens back, or put some liquidity, get some LP tokens back. Same for liquid staking, minting of synthetic assets, and, well, way more DeFi protocols. So what does it mean for us to integrate Shielder with DeFi? Is basically to translate this particular interaction pattern into a private interaction. So how would it look like? What we would like to user to do is to basically use the Shielder as a backend for a wallet. So basically, by default, keep all of the tokens in the shielder. And whenever user wishes to interact with any DeFi primitive, he would interact from inside of the shielder. So it's maybe important to point what's public here and what not. But Bob, keeping some tokens in the shielder, would send these tokens to the smart contract with this additional call data and receive the tokens back, which would immediately be reclaimed by him in the shielder. So would be put into the anonymity pool instantly. Then, if someone would like to watch this interaction from the outside, it's not, maybe what's important to say here, it's not entirely private, but it's anonymous, meaning that the Christopher here would see how many tokens have came into the smart contracts and how many tokens have came out of it. What he wouldn't see is who actually initiated the action. So the only public thing would be that, well, that was someone in the shielder. So in the perfect world, we would like majority of the users to actually initiate actions from the shielder. So that gives a very, very big anonymity set. And what's even more important, or even cooler, that this particular smart contract doesn't need to be privacy enhancing or in any way. So this can be any regular smart contract written in ink. It doesn't need to even need to support any specific private API. So this interaction protocol is so that it's able to basically mimic interaction from normal account. So it's not like we need to create yet another new private DeFi. We just want to introduce a single crypto primitive which will allow to privately interact with normal DeFi as we know it now. So that's the general way we would like Shielder to be used. And one more project which we're working on, and we think it's going to be important, is the ID system, which will become part of the Shielder. So, of course, privacy in DeFi is pretty controversial because, of course, most of you probably know what happens with Tornado Cash. And in generally, the problem is even not that that these protocols are not compliant to deploy or not compliant by themselves, but they are sometimes problematic for the users in the sense that having funds which interact with privacy protocols can be problematic, for example, because some centralized exchanges can make some problems when accepting such funds. So what's important is to allow users to provide specific proofs stating that these funds had nothing to do, for example, with blacklisted addresses. How we are planning to do it is with the ID system that will be hard-coded into the Shielder. So the users would have fully private ID, which they could claim. And then I'm not going to go into cryptographic details of how that would be implemented. This is complex and way out of scope of this talk. But what's important is that based on this private ID that would no one but the user would know, they would attach very specific cryptographic data to every deposit and every withdrawal. One important point here is that this particular interaction pattern that I just discussed a few minutes ago, this is not problematic because from the compliance reasons, because no tokens are changing hands here. So basically, using a Shielder, you can interact with, have a very complex history of interaction with DeFi. You can do it for literally years, and still, while you're using the same ID, it's not going to be problematic because when you exchange funds on the DEX, the funds you get are coming to the same address in the Shielder. So the only problematic actions are actual withdrawals, where you are getting out of the Shielder to another account. And this thing will also get this private specific identifier, which will allow you to, for example, you'll be able to prove that no transaction which is connected to your ID have ever anything to do with a publicly available list of sanctioned addresses. So if you have on-chain oracle which tells you which addresses got sanctioned, then you'll be able to generate proof, like general proofs of innocence, not only for a specific withdrawal, but for entire history. Whoa. Entire history of your ID. If you would like to reveal the history of your ID or part of it into any party, also you will be able to do so and prove the correctness of this particular part of the history. Also, what's possible, the shielder generally is able to operate with any token type. So you can have a token which, for example, will have withdrawal limits based on ID. So you can have some ID verification system, and then you can design a token in such a way that if the user doesn't have the ID verified or is at some low verification level, then it can have, for example, weekly withdrawal limits. This seems reasonable, for example, for stablecoins or assets for which the regulatory control is tighter than for normal utility coins. Oh, this is complex stuff, actually. So basically, this is how we see the future of a shielder. And I have two more slides, and I would like to skip over this one and just go to this one. So this is the late game that we see for DeFi on our chain. The next primitive that we'd like to implement is multi-party computation. And what it basically allows to do is it allows to keep secrets which are recoverable only when a specific committee colludes and basically majority of it becomes malicious. So we see it as basically the blockchain keeping secrets, or maybe the other way you can see it is smart contract keeping secret. So right now, with all the ZK technology that we have, it's pretty achievable already to have user-owned secret which are attested against the blockchain. But it's not really possible for a smart contract to have secret. For example, you cannot have a DEX with a secret pool state. Well, by default, anything that is owned by smart contract needs to be owned by block producers because they need to be able to compute the state transition. So they need to know everything about the state of smart contracts. So what we are planning to do, we are planning to allow smart contracts to have parts of its state in the MPC committee. So why is it useful? One of the use cases is the dark pools that Piotr mentioned initially. So normally when you interact with Uniswap, for example, even if you interact from the shielder, the amounts that are being traded needs to be public. That's because the state of the pools in the Uniswap is public. So even if you could somehow cryptographically conceal the transaction itself, someone could just watch the change in the pools in the Uniswap. So he could see that, well, okay, there was like 1,010 tokens, now it's 1,000. So that's obvious that someone just got 10 tokens out of the Uniswap. So even if the transaction itself would be private, well, you could infer it from the change of the pools in the Uniswap. So if the pools would be kept in MPC, then that's a dark pool. That's a DEX where the amounts being traded are not public. Yield strategy markets. That's a bit more complex case maybe, but what's already being done on multiple blockchains are protocols that had hard-coded investment strategies so that users can invest funds into these strategies. And usually it works like that deployers of these protocols code the strategies themselves. So whenever you, for example, invest in Earn Finance, you invest in practice in the strategies that are deployed by the core deployers of the platform. What would be really nice to do is a protocol where there can be a specific role of a, let's say, strategist or algorithmic trader. So anyone could submit his own idea for the strategies, and then users could choose which strategies they would like to invest in. What's problematic in this is that such a market could be very prone for copying strategies of other traders. So, like, if some strategy could be doing very well, you could easily just submit identical strategy as a trader and hope that some users will choose you over the other guy, perhaps because you are, for example, offering lower commission. So the way to actually solve this problem is to have it so that the strategies are executed in private, so they are not. It's not possible to actually copy the strategy itself and deploy it as a copycat trader. I'm on purpose leaving not talking about the common DEX because it's pretty complex and we just copied the slide from a way longer presentation. So yeah, I think that summarizes the vision. So the first part was what we're doing right now and what we're planning for this year. The MPC stuff, we already started work on MPC, although I would say that we're rather not planning deployment of it on the mainnet this year, but that's definitely part of a vision of how we see the private DeFi to develop in the future. So thanks a lot, and I hope that some of you will choose our bounties, and good luck.